Yeah, slightly. So I'm going to talk about why green zones are only part of the solution, and some of the work that our group and our other favorite center is doing on integrated land sea planning. Now, marine ecosystems are impacted by a variety of things. And at a local scale, we can do something about some of these, things like overfishing and runoff from the land. But typically what we do in conservation is, when we're conserving marine ecosystems, is we implement a network of marine reserves. And although that can do a good job at displacing some fishing effort in those places, it doesn't do anything about one of these really substantial threats that we have, and that's runoff, sedimentation, nutrients, things like that. So when we're protecting our marine ecosystems, we need to think a bit more holistically about what we do, and that might be looking to the land and prioritizing a variety of actions. Thinking about things like reducing grazing, stopping land clearing, or putting in national parks to help do that, or minimizing the use of fertilizers and pesticides, in addition to green zones. So I'm going to talk about some of the work that our group's been doing in this region. We've been doing a lot of things around the Coral Triangle, Fiji, and also in Australia, but I'm going to focus on Fiji today because we've been working with the Wildlife Conservation Society there for the last 4 years. So in the next 4 minutes, we'll talk about 4 years of work. Now in Fiji, they have a goal of protecting 20% of their land and 30% of the sea by 2020. And the Fiji Protected Area Committee, who we've been working with, is charged with informing these decisions, deciding where to protect, what to protect, all of these things. Now, the first question they had for us in this work is, how does protecting our forests influence the condition of coral reefs across the entire country in Fiji? Now, this map here shows those green areas are the currently forested areas in Fiji, the white areas have been cleared, and the blue areas are the reefs. Now, to answer this question, we had to estimate what the coral reef condition was across Fiji, and that's something that we have to model because no one knows that. So we created a simple little model, and it was primarily based on watershed-based pollution as well as fishing pressure and some rates of degradation. Now, just to repay the favor to Hugh, I realize this model might offend a lot of people in the room, and if it does offend you, Hugh's available at lunchtime. And I invite you to give him a hard time. But what we found in this, if we just take two really extreme scenarios, let's protect all the remaining forest in Fiji versus clear all the remaining forest in Fiji, what we found is that for coral reef condition, we can increase it by up to 58% if we protect everything. Now, this is really a silly scenario because it's unrealistic. We're not going to protect all the remaining forest in Fiji anytime soon. So the Protected Area Committee asked us, what bits of forest across Fiji are better than others? Where are we going to get the most return on investment? So we went shopping in the forest and calculated for every little sub-catchment where the biggest bang is for our buck. So we measured the return of protecting every catchment, and the return is just measured on improvement in coral reef condition based on our model, and the investment is a reflection of the cost of protecting that forest, which just reflects the foregone opportunity of, say, logging in that area. And what we found here is that the return on investment is going to be highly variable across Fiji. So what this map shows you here, it's all the remaining forest, and the dark red areas are the areas that are going to give you the best investment for coral reef condition, and the dark blue areas are going to give you the least good investment. And what this graph shows you here is that if you just take that red line, red part of the line on that graph, that's the best 2% of area that you can invest in. And if you compare that to that dark blue little sort of horizontal line at the top there, that's the worst 2% you can invest in. You're going to do 400 times better if you take the red bit versus the blue bit. So it's quite variable. But again, really unrealistic, like Bob Pressey was alluding to the other day, to protect the forest just for coral reef's sake. Because believe it or not, there's biodiversity on the land as well. And we want to try to accomplish those objectives while we're trying to accomplish the objectives of improving reef condition. So what we did is we developed a model where we tried to maximize coral reef condition as well as achieve this goal that Fiji has, is protecting 40% of every single major vegetation type on all their major islands on the land. And what we found in doing that, this is just one of the possible solutions of doing that, the results aren't quite as drastic, but we can still improve the condition of our reefs by up to 10% while still achieving these terrestrial biodiversity goals. And just finally, so this wasn't just a fun little academic exercise that we've been doing. It actually made a bit of a difference in Fiji. So Fiji's Protected Area Committee added some of the priority forests that we identified to a register of sites that they had previously identified, that the National Environmental Council endorsed. So what that means is if money comes available for protecting forests in Fiji, they're going to just go down that list and start protecting these things. That's all I have. Thanks.